Welcome. This is an overview of the Making Waves software. Making Waves is coupled with the AWG-34G from Southern Photonics. The AWG is an arbitrary waveform generator that can produce signals at up to 34 gigasamples per second. So here is the main window of the Making Waves software. The black portion at the top is your waveform viewer. In this section you see the voltage versus time of the waveform you have built up. Underneath, in this section, is the waveform builder. In the waveform builder section, you will build up different sequences of signals and add them, subtract them, or multiply them together to create the final waveform that you would like to create. So we'll run through a few different examples in this video. So you can see different operations that can be added here. Let's start with a PRBS signal. So we'll create a PRBS signal, and with the click of a mouse you can change the PRBS length. So let's start with a PRBS of 2 to the 9 and a peak-to-peak voltage of 0.5 volts. So here's the PRBS signal that we've created, and you can click on it and drag it, move it along anywhere in the waveform builder. You can also add operations to the sequences that you've built up. For example, here I'm adding a pre-emphasis filter of 18 GHz. This is to compensate for the frequency response of a cable that I have connected between the AWG and the oscilloscope. So I'll send this waveform to the AWG. We'll be able to see the resulting signal on our oscilloscope. So here is our 32 gigasample per second PRBS signal on our oscilloscope. Now I can quickly change that binary sequence to a 4-level signal. For example, if you wanted to do optical QPSK, you could use this to create your QPSK signal. Other things you can do is add headers to your PRBS sequence. Maybe you need a specific header in your system in order for the frames to be recovered properly. So here I'll generate a repeating sequence of 1010, and I'll place this at the beginning of my PRBS sequence. Now by just clicking on any individual sequence, you can change any of the properties. So here I'll change it to 0.8 volts peak to peak, just as an example. Now let's change it back to 0.5 volts for both the header and the PRBS sequence. Now by selecting the PRBS and the header sequence, I can add a pre-emphasis filter to both of these sequences. So here I'll add my 18 GHz. So you can see that the filter overlaps both my binary header and my PRBS sequence. By just a click of a mouse, I can change that PRBS to 2 to the 11. Now I'll send that to my AWG, and we can see the resulting 4-level eye on our oscilloscope. So let me clear this, and let's build up an even more complex signal. So you can add, say, signals from a file that you may have generated using MATLAB or any other application. So here's the particular sequence, and I'll send this to the AWG, and we can see the result on the oscilloscope. In this case, we've used it to write AWG-34G on our sampling oscilloscope. Now we'll clear this. Let me build up another waveform. So let's start with a, say, sine wave. We'll change the amplitude to 0.4 volts and keep all the other parameters the same. We can add a triangular wave of 500 megahertz. And let's change its duration to, say, 13 nanoseconds, and its amplitude to 0.6 volts. So now that I have multiple sequences on my waveform builder, you can see that there are there's a precedence. So whatever sequence is above any other sequence will take precedence. So in this case now, my triangular wave is taking precedence over my sine wave. So my sine wave will only show up when it's either above the triangular wave or on either sides of the triangular wave beyond the time sequence the triangular wave occupies. So let me add another sine wave, say 200 megahertz. Now we can build up more and more complex signals by just stacking them together. I can also select multiple sequences and then perform operations between them, such as add, for example, here, or subtract. So now I'm subtracting the triangular wave from the sine wave, or the sine wave from the triangular wave in this example, and you can see that the subtract operation is just taking place in the overlapping section between the sequences. So let me select the sine and the triangular wave, and let's do another operation. Let's add these two together. So now in the overlapping section between the sequences, I'm adding them. So to build an even more complex waveform, I'll add a square wave. You can see again the precedence is taking over, so the square is taking precedence over the sine wave. Now when I move it under, you can't see the sine wave until I move over to the sequence in time that's extending beyond my sine wave. So I can then again send this to the AWG. And it's as simple as that to build as complex of waveforms as you would like. So for more information on the AWG-34G, please visit southernphotonics.com or go to our YouTube channel and see other videos on many of our other products in the Southern Photonics line. Thank you.